Hello.
Hey, good morning.
I joined like a little while ago, but there was like nobody here. So I
Same,
went back to check Slack channels.
same. This
Yeah, I just looked at the agenda. I just joined as well. I don't see anything listed for today, so I will probably drop unless the lead shows up in the next minute or two.
Yeah. I can check real quick with others. Let's see.
Hello.
Hello.
Max,
It's a Joe. How's it going?
good.
How are you guys? Nilik, Jadit?
perfect. Can't complain. It's a beautiful weather going on Seattle for the last couple of weeks, so happy about
Unless there will be a smoke, I guess.
it.
Then I'll complain. Otherwise, good.
Unless there'll be a small what now?
Smoke?
Oh, is there like fire risk up there right now?
Not here in the West Coast, I guess, but there is a East Coast. I think there are some fires over at Canada. Not sure Vancouver, but I think there were on the west side as well. I was just looking at the weather map this morning.
Interesting. Are Surtesh and Rita, are we expecting them or no?
I have pinged, have not received any response yet.
Okay. Well, do we want to, let me create a new entry here. What day is today?
June 7th.
June 7th. June 7th. Just for proof things happen, there's a calendar entry now, or a notes entry. All right. Empty document. Did anyone have anything they wanted to talk about?
I didn't have anything on the list.
Oh, there's Rita.
Your audio works when nobody is here, Max.
Well, this time the audio interface is not plugged in, so there was nothing to futz around. I came pre-pessimistic in my hardware.
At least there were 3 people to notice it. So
Yeah.
still a win.
Hey, Rita, did you have any topics?
No, just trying to get caps in,
Slow
Tomorrow,
Monday.
PR deadline, just,
Yeah. What is? Sorry, Joe. I've sort of the mutation cap has dropped off my radar for a bit. How's that one going?
We're not doing anything on it right now because we're not going to try for it until 1.29, which isn't this release, it's the next release. So we had kind of gotten it stubbed out early to give people a chance to look at it. I'm still very interested in feedback for people that aren't overwhelmed with CAPS and PRR right now, but if you are, feel free to wait 2 weeks and then circle back on it.
Yeah. I mean, so for us, I think the thing you're most interested in is we're looking to get a prototype cell driver out. That's very much probably not going to be the final shape. Like it's in the constraint framework already, and I expect today or tomorrow to have a PR out that lets you integrate it with Gatekeeper and Gator, provided you enable it with a flag.
Oh, that's great.
I think there's still like a friction log in terms of stuff that could be easier in a non-admission control environment. I think most of it revolves around just the use of wholesale interfaces, which I don't know. It seems to kind of be the standard for Kubernetes, right? To create a universal interface and just use that rather than the slimmed down interface of, hey, this is what the code actually requires.
Yeah. Kubernetes has an unfortunate history of using kind of more like Java style interfaces instead of Go style interfaces. We don't have to though. So if there are areas where you'd like to propose a fix along those lines where we actually you say what you need instead of say what you offer, then I think we could make some adjustments. But yeah, it's kind of the norm in the code base. So when people merge stuff with that, I don't usually bucket unless there's a reason to.
Gotcha. Okay, thank you. That's good to know. Yeah, none of it's dire, but there's a lot of building of wrappers to mock out some behaviors that, excuse me, from what I could tell, VAP isn't using, though maybe it wants to use in the future. So that could be interesting to know too.
Yeah, I think we're pretty open to PRs that clean that kind of stuff up.
And because there's nothing on the agenda, I'm just talking, right? If people want to add something, feel free to interrupt me. But do you get a sense about variables?
Yeah, so we have Jared has opened a CAP update to add the variable support upstream.
Oh.
And that might make it in this release. I think it's fine. So his proposal is really straightforward. You provide an ordered list of variable declarations that would work a lot like what you would have if you just wrote code in a normal imperative language, where any variable can refer to any of the previously defined variables. The only constraint is you're not allowed to redefine a variable twice. You have to define it once and stick with whatever you defined, which is, I think, okay. And probably it looks a lot better. So that's actually really simple and allows you to do things like, define something, then use it in a validation rule, and then use the same information in a reason without having to like recreate the same expression or copy the expression into the reason. And
that's awesome. Okay.
yeah, it's really nice. The other thing that we're turning on slowly is the optional feature in Cell. We're going to have it baked into the code base in 128, and then in 129 we'll turn it on. And then if you need to roll back, you'll still have a working cluster. That's how we'll usually turn things on. That feature is actually pretty convenient because you can chain question mark, dereference operations, and then you can then once you've dereferenced an entire thing, it's very easy to manipulate it without having to have like a bunch of has checks. So I think that's actually going to be a game changer in practice for a lot of people. The conventions on how to use it are still a little up in the air, but we've found some examples of that working really well.
Yeah, 100%.
So I think once you combine that and variables, I think a lot of the agronomics get a lot better. And I think that's going to be really helpful, because we have seen people writing expressions where we're just like, oh no, that's just, I can't offer them anything better either. And so I think these two capabilities will kind of solve those problems.
It's as good as it can be made, and that's the problem.
Yeah, the problem is like I can't tell them a better way to do it. They just have a bunch of has checks, and sometimes I can be like, well, you could move your has checks up into the match conditions or something, and it gets a little better. But that's about it.
Yeah, I do wonder. I feel like a place to like push at things where they might break is stuff where you need iteration, but also want to form a message based on the results of that iteration.
Mm-hmm.
Like variables might help there, but because they're globally declared and you can't like define an expression mid-iteration.
Yeah, we should try some of those cases out. I mean, you can iterate and apply a filter, and then you could get a smaller list result back. So like you could basically run a search and find some deeply nested set of objects that are actually to be the problem ones in a variable, and then you could your validation would be rule is like, if that list is greater than 0, you're invalid. And then the message could be like, string join these together using some criteria to construct an explanation of what it found that was a problem. But we need examples of stuff like that, because it's not super obvious, and it gets into like, there's kind of two uses of Cell. One is the like, I'm doing basic expressions, which I think is really intuitive for people. And then the other one is like, well, I can't assign variables. Well, at least you can't today. And so I'm just doing full like functional programming, right? Like one expression calls map and filter, and like a lot of people their brains aren't really set up to do that normally. And so then like that gets out of their comfort zone really quick.
Yeah.
I think variables will help a little bit. But then like still like you're going to have to call filter somewhere, and
yeah, and coordinating probably two unrelated lists. Let's see. Let me think about like what I forget what the word is. Idiopathic. The worst case scenario for the expression.
Yeah, we've shown examples of like proving that two sets are disjoint and things like that, and like it's actually not that much code, but if you're not like comfortable with functional programming, it's not super intuitive, because we don't give you like just a disjoint operator. You just have to like write the filter logic, and that's not necessarily obvious to everybody.
Rita has some questions. Do y'all have any benchmark of representative cell match conditions?
I did some early benchmarking. I don't know if it's good enough to publish. And right now, I'm actually now is either a really good or really bad time to do it, because the cell authors are working really hard to optimize for certain code paths for various use cases, for various production use cases. But the couple things that I think are interesting about cell is that once you've compiled a cell program, the overhead to step into cell from Go is very low, because you're not building a sandbox. And so that has a really nice property of being like very, very close to zero for all practical purposes. The benchmarks I ran were mostly to tune our cost system. And I was seeing what I thought was between like 4 and 10x slower than native code for most instructions. And everything's like the cost of instructions when you think about benchmarking. That seemed pretty promising. There's a lot of cases where you actually call into native code. So like if you're doing an expensive operation like a regex operation, you very quickly just step into Go code, and so you're getting one-to-one performance. And we don't like, it's not like one of those interpreters where we re-implement that stuff at a higher level. So that's kind of how that works. Allocs, I haven't measured as well. Cell is designed to try and make it hard for you to allocate memory, but that's going to change when we add the variable stuff in, because you're going to be able to like construct an intermediate result. And the size bloat of cell objects versus just normal Go objects is, I think, pretty low, but I haven't actually measured it. So yeah, that's kind of where I'm at now. I have some spreadsheets if anybody wanted to set something up, and we do have some basic benchmarks, but
Yes, please.
yeah.
I mean, I tagged you on that VR again because we're looking at it for that cap, but the more I'm thinking about it, the more I'm like, wait, this is just a general thing for cell, right? It's not specific.
Yeah, and that's
we should
one of the
just do
reasons.
it one shot, you know?
Yeah, that's one of the reasons why I'm a little cautious about doing too much benchmarking on the Kubernetes side, is because Cell's going to keep changing stuff, and I feel like the Cell team is better equipped to benchmark and keep up to date on what their actual metrics are.
Yeah, like having some kind of readily translatable benchmark though could be good, right? Like, what is the cost of writing this in Go versus writing it in Cell? Like, but you get more flexibility, right, for a user if it's in Cell. So is it, what are the trade-offs there?
Yeah. I'll talk to Tristan about it too, since he's the author of Cell, and see if they have any interest.
Is there an issue for this already? If not, I can open one.
Yeah, I would open one over on the
Issues.
the private
Okay.
Go Cell side. Cell Go.
Huh?
Yeah, here's the repo. That's probably the right place to open it, and then just links to that. My guess is that Tristan does have a pretty good set of tools that he's using right now, because I know he's optimizing right now. So he might be able to give us something, or figure out a way to get something.
Okay, I'll open an issue there.
Cool.
Thank you.
And I'll find my old sheet.
What else? Controller runtime. Oh, good.
Yeah, I was gonna ask, like, once you bump the framework stuff in Gatekeeper, I guess we can start testing at least the audit part, right?
Oh yeah, well, it'll all be functional, right?
Right,
It won't. it won't try to use the native validating admission policy embedded webhook, for lack of a better word, but it will read the policies and enforce them as far as our engine
Okay.
allows it to, right?
Once I'm done with the KEP stuff, maybe I'll just kind of like maybe try one of the example policies we have and just like see what does it look like with the new driver, right?
Yeah, and I know that's also one thing that Joe is interested in, is as we like look at our library of constraint templates, right? And not all of them are going to be convertible, right? Some of them have referential data, for instance, but for the ones that are, what does it look like? Is it easy to do that conversion, write those expressions in cell, or is it, is there something missing that might make that easier?
Yeah, you probably have to experiment to see if there's any like unknown unknowns there. I can't think of anything like, as long as you give the cell environment the data it needs, it seems like having multiple objects is a pretty well supported thing, but there might be
multiple objects. Sorry,
like for referential stuff, like comparing two things. Is that what you're talking about?
Yeah. So this is, I was thinking more just like some of the stuff that we have might be valuable just for raw VAP, right? In the sense that it would be a stress test to even write cell. But yeah, referential data, I think, could be interesting in cell. Like I don't know if VAP is interested in that, but for us, it would be a good stress test around, like, we would want a common cache. We probably don't want to like duplicate our cache per language. Double the memory, double the
no, you would probably want that.
And also a way to like efficiently query that cache, right? Like give me all config maps for a certain namespace or whatever. And so that sounds to me like if we wanted to do that in cell, creating an embedded function that can read the cache with some kind of like set of query parameters.
Yeah, you can look at what we did with the authorizer in VAP as an example. It is actually really easy to do. It's a little contorted to write cell functions that call the native functions, but once you learn the recipe for it, then like it's actually pretty trivial. So basically, as long as you can define a pretty reasonable Go API that will give you access to your cache, wrapping it and making it accessible in cell is kind of a routine thing.
Off the top of your head, is variadic arguments something that the cell to Go bindings would support?
Right now, no. You can provide in a list of arguments as long as they are homogeneously typed, right? So that works. And we actually ran into a problem because Kermit was trying to use that to give us a string.format type operation, kind of like Go has, where you wanted to provide in like variadic args, but they had to be heterogeneously typed because one can be a string, one can be an int, and there was no way to do that. So Tristan is working on something to support that kind of thing. But yeah, you always have to represent it as a list into the input instead of an actual like first class variadic arg. So if that's a problem, then no, we don't have it, but a lot of things work reasonably well that way.
And it sounds like you also can't use interfaces then, because like list of interface seems like it would fit for string formatting.
Yeah, the type system in cell is a little interesting for some of these cases. So how do you explain this? It doesn't go, cell doesn't have interfaces to speak of. It does have a couple kind of specialty types, but it doesn't have like a top type. So it does have this type called dynamic, which has special meaning, but it's not exactly the same as a top type. And so for that reason, like usually you have to be fairly crisp on like what types you're expecting.
Gotcha. Okay.
It
Okay.
does create some problems here, right? For this very specific case where it's like, well, if this was Go, I could just say any is the type, and then I can just take whatever I want as a list, and then it's then I'm good. Cell doesn't quite have that equivalent.
Yeah. What was there any-ish type again? You were saying?
There's something called the dynamic type. And so what it allows, the main purpose of the dynamic type is actually really handy. If you want to have some type of gradual typing where you want to have really strong compile checking on some of your inputs, but some of the others, like, I don't know what this is, you're going to just have to at runtime do type checking, or make valid assumptions that you know that you are correct about. You can do that, and so you can provide some things as in being dynamic, and then the type checker just basically says like dynamic matches everything, right? Like you can do. I think inequality is valid. If I do an addition, I'm going to assume the result of that addition is also dynamic because I don't know exactly what number type that would be. And so it kind of like the type system understands dynamic and is able to use it. If you don't have any dynamic, you have very clean full type checking. Once you have dynamic in, it kind of like propagates to everything it touches and interacts with, and then all that's dynamic. And so you just end up with less static typing. It can be nice, like we use it in VAP when you can have an object that you don't know if it's a pod or a deployment or what. And so we just say it's dynamic and you just kind of do what you want. We also will switch out the type. So we'll if you can only take a pod or a deployment as an input somewhere, we will compile it using the dynamic type, but then we'll also compile it once using the pod type and once using the deployment type. And we will give you that informational type checking on both of the actual concrete types in your status, so you can know if you had any compilation errors. But you know, we still let you run it.
You still what?
We still let you run the expression even if you have compilation errors against a concrete type. So we call that informational type checking.
Still let you run the
right. So we actually run the compiler more than once. Right. We'll run it once dynamically, and we'll actually store and use that program later. We'll then run it again with pod as the known type, and then run it again as deployment as the run type. And we'll report all of the compilation errors that you get for any of those types into the status.
I see.
And you know, so the simplest form of this is, say that you have a VAP that only matches a pod. We will compile it against pod. We will give you any compilers against pod, but we'll put those in the status and we'll let you run even if compilation failed there, because we'll use the dynamic type at actual runtime.
Interesting. And is some of that because you can't really do like type switching, right? Like if you want to support both deployment and pod, and you have like a gateway check.
We can't say like the type here is a union of pod and deployment.
Right, but could an author of cell go like, if pods execute this code, if not, don't, and then have a separate expression that handles deployments, and yep. That statically would work, or you need dynamic typing for that?
You could do that statically if you represented it right? Like, so you could have like an input where one field is a pod and one was a deployment, or you could have two variables as input where one's a pod and one's a deployment. And then everything would be typed. And that would be roughly equivalent to having a union. But you could also just have a union where it's like, conceptually, you can't do this in cell, but conceptually in a type system, you could be like, this type is either a pod or a deployment, right? And then the type system would check it and know what to do. And you could, if you were using like case guarding, you could make sure that all your code makes sense.
Right, but as you're saying, Cell doesn't do that, and that's
exactly.
And that's why dynamic, or no?
It's part of why dynamic. It's also because we want to allow the duck typing, and there's no interfaces. So like if you do have a pod and a deployment and you're just accessing the metadata, or in some very rare cases, if you like literally had the same field at the same location, then you can just access it and everything just works, and you don't have to like special case that. So part of it is just the simplicity. Part of it is because of the type system is not quite there.
And if you don't have any type information, like it's not, there's no resource matcher, then there's just no type checking. Is that right? Or
yeah. If you don't have any information about something, then you just go without. I don't think there right now. I think we should have information about everything. I guess I'm trying to think of any edge cases. No, because CRDs, we always know the type information now. But
right,
I mean, you could pass something in without type information. It would still work if you could get one in.
Well, metadata-based stuff, right? Like, I don't, like, technically metadata has a type, but I don't know.
Like banks of strings, and yeah.
Yeah, and there's no way to express, hey, this VAP is only looking at metadata, so validate that input, it matches the metadata and mask anything that's not metadata, right?
Yeah.
Okay.
Yeah, I think that works. Yeah, you could have like a special metadata type or something, and then you'd be good.
Gotcha. So possibility, but not a reality right now.
Yeah, that's not a reality right now.
Is there a concern? I guess not, because I was thinking about version skew. Like, let's say where Gatekeeper is running validating admission policy locally, right? But the user is on an older version of Gatekeeper, so Kubernetes has moved on, 5 versions or something, and so now there's like a new pod field that, as far as Gatekeeper knows, isn't part of the pod spec. Would that ever cause an issue?
It shouldn't. I mean, the way that we do to backwards compatibility in Kubernetes is like very strict. And so if you're not aware of a field and you wrote a policy that made sense, I think would be considered unsafe for us to add the field to Kubernetes.
Well, but in this case, what I'm saying is that Gatekeeper is running, let's say it's shift left, right? So it's Gator, like a command line, doing static validation, right? And they have something that works on the new cluster, right? Let's the pod has like must be super secure is this new field, right?
Yeah.
And they write a policy that says, well, that must be set to true, right? But for the static version of K8s of the version of Gator that they're using, must be super secure. The field doesn't exist, right? So would they be able to add that policy?
Yeah, that's a problem. If you're wanting to add a policy that forces the use of a new feature, then you're in a problem, because if you're not aware of the feature, how can you possibly say, I'm going to force you to use it? I don't know any way around that other than just like making sure that the skew policy is sane enough that things get caught up, right?
Well, so in theory, like the only problem here in this scenario that I can imagine would be with the type system itself, right? Like the cell that the author would write would be correct because it's, you know, they're aware of the field, they're specifically writing a policy for that field.
Yeah.
Sorry, go ahead.
I actually think that the way that we have VAP set up right now, if you wanted it to fail at shift left time, if a field is not there and it's not even defined in the schema, I think the cell expression will just work because we're using dynamic. It'll just be like, nope, that field's not there. I mean, it's not a valid field, so until it comes into existence. Now, there's also the possibility that you could get a typo in a field name and the field is actually there. And as kind of a corollary to this is that would also not be caught. But no, I think that works. I can't think of any reason why it wouldn't. You would probably get an informational type error being like, I don't think this field exists, but you would still be able to write the cell expression and you would still be able to check the field.
Yeah, like that to me is the happy medium that I'd like to like be sure stays, is like having those warnings definitely beneficial, but being able to validate the content of unknown fields like lowers the barrier to rollout essentially.
Yeah, and I mean that was one of the reasons why we had to do dynamic is because we were trying to reason about like how do you even give somebody a YAML file that expects something to compile a certain way and then they loaded it in their cluster. You don't even know which fields you're loading, which cluster you're loading this VAP into, right? And if that doesn't have that field yet, what should we do? Should we just not allow you to load the thing in? Should you know, and so our decision was to just do everything dynamically. It solves that problem. It makes CRDs a lot safer because we know that people make pretty sketchy schema evolution changes to CRDs. And so, you know, this is an attempt to make that a little less fragile. We're doing some other things around CRDs to make that less fragile too, but we also want to give people a checker so they can know that their change was safe. But yeah, that will never change. We would never go to a stricter form of that because like we're already going to beta. We will go to GA with that, and at that point we're pretty API locked into the idea that like you're allowed to have a cell expression that references a field that doesn't even exist, but that might exist later or that exists in another version already.
Yeah, and I think that it covers this use case as well, but another reason would be for like shift left, the CRD may not be available to inquire about the expected schema.
Yeah, and this needs to still work in that case.
Yeah.
Hey, I'm just trying to take notes. So it sounds like because the cell expression is pretty dynamic, we're actually not doing strict validation, right? So in essence, if people use a field that is not recognized in the expression, it will still work. Is that right?
Yeah, so what we do is we do a form of gradual type checking where the input object is not strictly type checked. It's treated as dynamic input data. So if you say is 1 less than the string A, you would still get a compile error because cell can't compare strings and ints. But if you asked if object.spec.foo is less than 1, you would never get a compile error there, even if that field was a string. You would get that at runtime. And even if that field didn't exist, you would be allowed to write that cell expression.
But you would get like compiled warnings from like these multi-stage compilings.
Yeah,
potentially.
We will still, if you look at the status of that object, you still might see informational compile errors that tell you that, hey, we don't think this field exists. But you're still allowed to load in the cell policy, and you're still allowed to run it, and you'll still only get the error at runtime.
That's interesting. Oh, so, I'll let Rita finish. And then...
No, I'm just like trying to grok what you're saying. So let's say I think the additive seems like it's addressed, right? Because if it's an unknown field, it still processes. That's good. But it seems like the opposite may not be true. Like, so if, let's say in my expression, I'm using a field that it has been deprecated, let's say, and it's no longer valid in Kubernetes APIs, would the expression still work?
It
Because
will.
it's missing, right? Like, sorry,
Yeah,
the
no,
field
you
will
will.
be missing.
It's you kind of get the behavior you would get if you were using a fully dynamic language in some sense. Like you're still allowed to write the code, and at runtime, whatever happens, and you might get errors at runtime. So say you have an alpha API and you wrote some cell against it, and somebody decided to delete a field off an alpha API, because you can do that. Then if you were expecting that to be a required field and always there, and you couldn't tolerate it not being there, and all of a sudden it's not there, you're going to get a runtime error. Your cell expression is going to break.
Okay.
But
So
the
old
good
things
news
will
is
break.
if you're doing that against a V1 API, like backwards compatibility kind of protects you. If your cell expression ever worked, it should always work, because we wouldn't remove a required field, right? Like, and if it was an optional field, then you have to tolerate the possibility that the value is absent anyways.
Okay, so let's say if I have a policy that applies to multiple versions, then we should have multiple expressions referencing different fields.
Yeah,
to
if you're like validating both a beta and a V1 API, sometimes it's safe to write a single expression, but I would be very careful. Like in production use cases, I would probably only write a cell expression against one version of an API, because with beta, it's not as bad. If you were doing beta in V1, that's actually pretty safe, as long as you check to know that they both have the field. But for example, like with CRDs, a bunch of stuff was moved around, so fields weren't at the same location as beta and V1. So if you were to write that, you would want to make sure it works. If you do have it working on both versions, then it's going to continue to work, because we have backwards compatibility requirements on both beta and V1. But if you were to do that with alpha, of course, it could break. And if you wrote it for V1 and assumed it worked for beta, that's also really sketchy, because fields have sometimes been moved between beta and V1.
Do you have an example of this you could share? An expression that works for multiple versions?
We could find some.
Constraint templates would provide a trivial example, because we have V1 alpha 1, V1 beta 1, and V1, and they all have the same schema.
Yeah, a high number of Kubernetes resources had identical beta and GA APIs.
Yeah.
So if you happen to know that those are identical, you could do that.
You could also like version gate the cell expression, right? Like do a trinary operator or whatever, saying like, if is V1 alpha 1, then do check, otherwise return true, and just nullify that particular expression.
Yeah, and you can do that because you can access the resource information, check which actual version you're getting in on your request, even if you matched multiples. So you could just break it across multiple expressions and gate which expression has which version.
Which is funny. Oh wow, you could use variable composition too, to like, if you had like some abstract property, like let's say capabilities, right? That's something that can be defined in multiple places on a pod, if I remember.
Yeah.
You could define a variable for capabilities defined at the like container level and capabilities at the pod level, and then but you can have multiple pods. Okay. So that's an example of.
Yeah, there's the classic one, of course, is that there's init containers, normal containers, ephemeral containers, and when sidecars were introduced, we made a point of not adding a fourth one, but that was actually considered. But you could have a variable that basically concatenated together all the containers, at least for the fields that you cared about. It's a little weird because ephemeral containers are technically a different type. But you could like, if you just didn't care what kind of container it was, but wanted to check something like about the image of the containers, you could grab all of the images from all the containers and put it into a variable. And then in all your validation rules, you would just be like, if a container image has some property, fail.
The reason why capabilities is, I want to call it a breaking case because you could make it work, but definitely a stretch case, is that the composition of capabilities is different per container, right? Like you, wait, no, okay, oh no, it is, right? Because like if defined at container level, use containers capability. If defined at pod level, but not container level, use pod level capabilities. Is that right?
I'm not sure I followed all that.
Sorry.
Sorry.
Basically, I'm trying to come up with cases that stretch the notion of like just static variables per execution. And so it would be nice if you have, because there do exist in a couple of places in the K8s API, sort of non-trivial compositional situations, right? Where the source of truth depends on the value of separate fields in different parts of the schema. But then also, like, and Pod has this in a couple of places, I believe, where it's technically a per container resultant, right? That you need to, for every container you run, have a set of capabilities, for instance. So that calculation of, well, what is the end result for the capabilities expression changes on a per container basis. Does that make sense?
Yeah, I think so. Yeah, sorry, I'm not having any brilliant thoughts here. Yeah, I think you might be onto something. It might be good to like get some examples or something.
Yeah, I wish there was something, because I think capabilities that just clobbers or doesn't. If there's something that is more nuanced than that, that would be better.
Yeah, I mean, we are definitely like, we're definitely going to push up against like the boundaries of like the way that the types are represented in Kubernetes, because we're going to want to like treat things as the same that the type system in, I mean, that the Kubernetes types don't know the same. Like ephemeral container and container are, for the most part, the same with some slight differences. And a lot of times you would want to treat them as the same, but technically they're different types with no direct relationship between each other and no exposed interface that says they're common. And so, you know, having to process them separately is kind of annoying.
Right. But there you could do kind of a gradual variable definition, right? Like have the two lists of containers, let's say. So like there's the list of like full containers, right? That should support anything that any container supports. And then like add a second list that's like all containers, right? Ephemeral included. And which one your expression accesses would just be dependent on whether, you know, the particular check is valid for whatever set of containers. So
we should try some of these out. I want to see what happens.
Yeah, I am curious because you had mentioned status. The last time I looked at the code, kind of the place that status was at was sort of lazily derived. Like you would try to compile cell codes, but then if there was some kind of error, you would only really retrieve that error when it came to evaluation time, right? And would like pull that error from a cache or something, and instead of returning a result would say, hey, actually, I never compiled.
Yeah, so it's not quite that bad. So we do an upfront compilation of the cell expression, assuming dynamic types for inputs. So if you write just garbage, like you write something that is just syntactically incorrect, you're not going to be able to put the VAP into the API server. It's going to reject it with an immediate error saying that this is a valid cell. And that's true even for things like if you're accessing information about the requests or trying to write an authorizer expression or things like that, where we know all the exact types and they never change, we'll do the same. So you'll get an immediate error. You're not allowed to put it in the API server. It's only the cases where you've got a dynamic input like the object itself, and we have no idea what the format of that thing is, that we go fully dynamic. I think the main gap that we could do better with is all objects have the exact same metadata. And while technically we could add fields to metadata later, I think we could have made a better argument that metadata is stable, and we could like give you an error if you write a cell expression that tries to access something in metadata that's just not there, or whatever, or assumed that the type was wrong or something like that. So that's probably the only area where I think we could have maybe been a little bit more aggressive. But for the most part, like you do get the full gradual typing. Like if you give it a bad expression and we know for sure it's bad, we'll fail at the front door and you won't be able to put it in. All of the later type checking is just like if we say you're only matching deployments. So we'll imagine that object is in a deployment, and then we'll do a compile check with that, which is a little more strict, and tell you if there's any problems.
Right. Well, that's the case I'm interested in, just from the UX of it.
Yeah.
So is it the case? So if I create a validating admission policy that says I'm using deployments,
Yeah.
right? But I'm accessing some unknown field, right? First of all, my understanding is that would go through and you try to treat it dynamically where possible.
Yeah.
But you would also mention that there would be some kind of warning saying, hey, as far as I'm aware, that field makes no sense for deployments.
Yeah, that's right.
And that would be reported. So is it reported on the status field of the validating admission policy at apply time or close to, because there's a reconcile? Or is it do you only get that error when you actually evaluate the policy against an inbound deployment?
You get it on the status as soon as the reconciler writes it. So for the most cases, it seems to be immediate, right? Like if you wrote your validating admission policy and then read it back, and the reconciler is running in a normal healthy mode, you'll immediately see some warnings in the type checking of the status telling you like, hey, I don't think this field exists.
So in a Kubernetes upgrade situation, if you're running multiple API servers, and so one is on a more recent version and the other on older versions,
Mm-hmm.
Is there any kind of like status fight issue where the newest version says this is fine, I know what this field is, but the older ones are like, nope, don't know it? And
yeah, this is a really good question. So the way it's going to work, and this is going to get better over time, the way it's going to work right now is that you're going to upgrade the API servers, and you're going to have one controller that's won the leader election as the controller. So this is going to be the kube controller manager. It's going to have whatever open API definitions it knows about at some point in time. During the transition, it's really hard to know which of those two it's got, because it depends on which API server it's getting open API information from. And so there is a period of uncertainty during the upgrade where it might be reporting on the old one or it might be reporting on the new one. Once that transition is completed and it's using the newest stuff, then it's good. This will get better when we add a feature that's going alpha in 128 where the API servers are actually going to do peer chatter with each other. and they're going to agree on what version of Open API to show even during an upgrade, and then that will become uniform. And then this story will get a little more sane, right? Like there will be this very clear step where once the API servers start upgrading, they're going to very rapidly be showing their latest API, Open API information. The controller is going to get it. The controller is going to start using that. This is still all eventually consistent, but there wouldn't be like new old transitions happening, right? Like there would be one very clear step. It would happen pretty rapidly.
So is it the case, if I'm running 3 API servers, are you saying that there is one leader API server and that one only ever is the only one to receive inbound REST requests?
No, it's not quite that. So what will happen, there's two parts to this. So once the thing I'm describing is called ViewVip, the peer processing. When we do upgrades, the API servers are going to be announcing into etcd which resources they're able to support and what their Open API information is. And then we're actually going to proxy request to an API server that can handle that. So that feature has a lot more implications than what we're describing, because it means things like that the garbage collector will still be able to access old information that is being deprecated out, which is one of the main reasons we're adding it. But it also means that if you're upgrading and you've upgraded one of your 3 API servers and you want to start using a new feature of that, all requests that you make, even if it's through a random round robin load balancer to your API servers, will be supported. If the API server that you hit directly doesn't support that feature yet, it'll side route it over to another API server that can proxy that back.
And you had mentioned one API server is the controller manager, but
it's technically a different process. The controller manager is actually a dedicated binary that's out of the API server, and that's where the type checking is going to happen. And those are leader elected. So their HA mode is that you have 1 active and 2 passive, and there's a leasing that keeps the active one active. And if it fails to update its lease, a replacement will hop in and take over the job.
And what's interesting about VAP is it controls how I can update the notes. It controls how the API server behaves, right?
Yeah.
So it's running in process with the API server is my guess, right?
Yeah, that's right.
So there's something that's at least reading these VAP resources. Is that separate from the thing that's reporting the status, or?
Yeah, there's actually 2 things going on. So the API servers themselves are going to load up during startup. They're going to load all the VAPs they have, and when one is added, they're going to be watching and seeing that it got added, and they're all going to pick it up. There is during startup, if you've already have them in etcd, when the API servers start up, they're guaranteed to actuate the ones that were in etcd. When you add another one to if you write a new VAP to any API server, and there's 3, there is eventual consistency where all 3 of them will start enforcing. So there is a brief period there where, depending on where your request goes, you may or may not get enforced for a couple brief moments. And if somebody was deliberately trying to look for that by sending a lot of high-speed requests, they might even be able to observe it. In practice, you usually can't, but in theory, you could. Once they're all active, they'll all stay active forever. So there's eventually consistency turning on or making a change to it. The controller that's watching the status, because the status is informational, it's also eventually consistent, right? Like you will write a VAP to an API server. The controller will be watching, see that, run all the compilation, and then write the status back to that object, which is written to etcd, and then all 3 API servers will see that and start serving that status information as well. But because it's only informational, it doesn't really affect runtime behavior. It just affects what you can see. And once it's in etcd, then all 3 API servers will serve reads on that.
So the thing that ingests for actuation is separate from the thing that ingests to report status.
Yeah, right. Yeah. So the API servers actually directly actuate off the object in etcd without a controller being involved. And the controller is just for updating the type checking. And that's mainly done so that you have one thing that reports the type checking.
Interesting that the, okay, so I'm just thinking back to the code here. So you can create a watch. It creates a watch and it creates, they kind of called it a controller in the codes.
Yeah, well, what's interesting is when we first added type checking in the last release, we put it straight into the API server. So the API server actually had two controllers for admission policies. One that actually loaded in stuff into the admission chain for enforcement, and another one that watched and then wrote the type checking information. And I think we may have even shared some of the controller code for those. But now we're splitting the type checking out into a completely separate controller and then relocating it into the kube controller manager.
Okay, so they are both like code-wise controllers, both the thing for actuation and the thing for ingestion. It's just they live in different places. And
yeah, this is actually an exceptional case in the Kubernetes. Kubernetes has very few controllers that are actually in the API server. Almost none. There's one for CRDs. There's one for this feature because it is entirely functional if you only have an API server. And I think there is one for some API server information that shows up in this API. So there's very few of them. Almost all other controller loops exist outside of the API server.
Gotcha. Okay, thank you.
Yeah.
All right. Sorry it turned into a let's grill you on BAP stuff.
No, it's fine. That's why I'm here. Make use of it. I won't always be here, but I'll try and make as much as I can.
Yeah, it's good to see you.
Yeah, good to see you, Max. Later.
See you.